Hi, everyone. I just wanted to take a minute to talk quickly about some of the symbols for logic and to make sure that we're all set with understanding um, what each of them represents and how to set them up. Okay, so luckily for us, logic at this point is nothing really more than symbolic notation and true and false statements. So, what we're starting with is we're starting with statements. And a statement, by definition, is just something that is true or false. It's not a question, it's not it's not a command or anything like that. It's just a something that is true or false. So, today is Saturday. True or false? That will depend on what day you're watching this, but I am doing this on a Monday. So for me, that is false. All right. So we're just saying it's false. Whenever you're dealing with logic, you're either going to be using, false or zeros and ones, whereas zero would be false and a one would be true. I'm just going to stick with the F and the T for clarity. Today I have math class. Again, I'm doing this on a Monday, so that for me is true. 1 plus 1 is 2. That is always true. And then 3 is less than 1. That is false. So all we're dealing with statements is we're just dealing with things that are true or false. They're not sometimes true, or they're either true or false. That's it. True or false. There's no kind of question in terms of like, well, maybe. No, it's true or false. That's it. And they can't be both true and false. There's no way it can be both Saturday and not Saturday at the same time. There's no way you can have math class and not have math class. There's 1 plus 1 is 2. There's no 1 plus 1 is not 2. That's it. There's no both situation here. So conventionally, when we're indicating statements, the first statement that we do is going to be P, and then the second statement is going to be Q. Why we've done P and Q, I don't actually know where that comes from, to be perfectly honest. I can look that up. But we do P and Q. And then if we get into more, we would do like R and S, and then, T, U, and B, and so on and so forth. But usually we're sticking just with P and Q, and then maybe R. When we get into the next section, you'll see why having more than like 3 can start getting annoying in terms of logical understanding. But it is feasible to have more than just these 4. All right, so we're going to definitely start with P and Q, then we'll move to R and S. So next step in the wonderful world of logic is negations. So if P is a statement, the negation of P is another statement that means exactly the opposite. So all we're doing is we're negating it. We're denoting it by either this little like tilde P. There's another symbol like that P. Either of these would just mean not, or these are negation symbols. Either of these are fine. I'm going to be using this one because I can type it a lot more easily than I can this one, but you will see this one on occasion. So don't worry if you see either. They mean the same thing. All right, so, and it's read as not P. This is not P. Exactly. So if P is today is Saturday, not P is today is not Saturday. Or if today is I have math class, not Q is today I do not have math class. Not R is 1 plus 1 is not 2. Not S is 3 is not less than 1. All right, so we're really just putting the word not or isn't or something like that in there to negate it. And all that we're doing is we're just making it the opposite. So anything that was false, when we negate it, so not P, that's true. Not Q, well, that's false because it originally was true. Not R, that's going to be false. And then not S is going to be true. All right, so when we're negating it, it's going to have the opposite. Okay, so if we look down there at the examples, I believe it's the one that we just went through. So today is Saturday, then today is not Saturday. If it was true, it will be true. You can't have a situation where both P and not P are true at the same time. You also can't have a situation where it is both P and not P are false at the same time, right? That's the whole point of logic. We're saying it's this one or this one. There's no, we're not dealing with gray areas. We're dealing with this, that. All right, so now we're gonna formally put some statements together. So up until this point, we've been just looking at individual statements, and now what we are going to do is we're gonna combine them into compound statements. And there's two different ways we can do compound statements. Much like compound inequalities, we have and or problems. In logic, an and is called a conjunction. And that's just because you're literally putting an and in between it. And what's the most famous conjunction other than and? So the way that we actually denote that is we're saying if P and Q are statements, their conjunction is the statement P and Q. And we do this using this symbol, this little caret looking thing. Okay. And all we're saying in this sense is if your P is the statement, I have a dime, and Q is the statement, I have a nickel. P and Q is I have a dime and I have a nickel. That's it. That's all that we're doing when we're putting these together. That being said, in order for the statement to now be true, the compound statement, they both need to be true. That's kind of the whole point of and. Like you wouldn't say I have, cows and chickens, and when you only have chickens. It's just not a true statement for you to say you have both and then only have one. I have cake and I have cookies. Well, if you don't have both cake and cookies, it's a problem. I have mega stuff and double stuff Oreos. Most people are very divided on that, and most don't have both. So you get the point. You need them both to be true for this statement to be true. So the only situation where this is true is if both P and Q are true. So today is Monday and I have math class. Well, that's true because when I'm making this video, it is Monday and I do have math class today. So that is true, okay? It's when they're both true. If, again, one of them is true, today is Monday and I have chickens. Well, that's not true because today is Monday, but I don't have chickens. Or, today is Tuesday and I have math class. Okay, well, today is not Tuesday in this video. So this whole thing is not true. All right. So there's only one situation where it's true, and that's when they are both true. So an example down here: Tallahassee is in Florida, and Orlando is in Georgia. Obviously, Tallahassee is in Florida. Orlando is not in Georgia, so therefore this is false. Okay. Now, moving on, the or, aka the disjunction. So, and as a quick reminder, and or. By the way, you can do compound statements with like P and, not Q. That's fine. You could do, not P and not Q. You could do not Q and P. It doesn't matter. P and Q is the same thing as Q and P. These are the same. It doesn't matter what order. Ordering has no effect at this point. Okay. Other piece of information, the disjunction. So again, this is and, that is or. It's the upside down version of that. And all we're saying with this is a disjunction. That is, we're saying we have two statements, P or Q. And really, I don't care which one is true as long as at least one of them is true. Today is Saturday or today is Monday. Well, Monday is true. So this whole compound statement is fine. Because we're saying either or is right. I don't care which one. Both could be right. Today is Monday or today is not Monday. I mean, you wouldn't write that, but I mean, it is technically true. It is Monday or it is not Monday. One of them is true. They could both be true, Today is Tuesday, or 1 plus 1 is 2. That's true, right? Because 1 plus 1 is 2. And if today was Tuesday, they would both be right, and it would still be right. So the or, again, we're just saying only one of them needs to be true. The only situation where the whole statement will be false would be if you ended up in something like this. Today is Tuesday, or 3 is less than 1. Okay, well, it's not Tuesday, and 3 is not less than 1. So neither of those is true. Therefore, the whole statement is false. And again, it doesn't matter in terms if I do order, like if I did P or Q or P, it doesn't matter. The order is the same. And again, you can combine these with, negations. So you could say not P or Q. You could do not Q or not P. Doesn't matter. The order doesn't matter, and you can include the negations as long as these are just specifically statements. Okay, so that's a very brief overview of symbolic logic that we're going to be dealing with going forward, and this is going to help set us up for when we finally get to proofs. All right, have a great day, everyone.